So yo, what's up guys, welcome to another amazing video of my channel Smarter Everyday. And in this video we're gonna continue with the same chapter that we're doing in the last video, that was force and motion. And this is gonna be chapter part 2, you may count. And I know I couldn't upload video for like a 1 month, but from now you will get regular video uploads. So why to wait, let's begin. But before starting, don't forget to like, share and subscribe to my channel. So now let's begin. The points that are going to be covered in this video are distance, displacement, speed, average speed, and we're gonna do some sums on these topics. And the answer key of those questions will be in the description. So but I prefer that you first do the questions and then see the answer key. So now let's continue and move to the first topic, that is distance. So now we are going to study this image that is given to the bottom right, and we're going to see what is the distance of the car. So in order to begin, first you have to specify starting point. So the A is the starting point and C is the ending point, but there is a break, that is B. So now to calculate the distance, we see that it moves from A to B first, that is 4 kilometers, and then B to C, that is 3 kilometers. It is given over here. So the total length covered by the car is gonna be like AB plus BC, that is equal to So AB plus BC, that is equal to 4 plus 3, that is 7 kilometer. So now the distance, guys, distance of the car is 7 kilometer. So now what is 7 kilometer? Sorry. What is the distance now? So let's see the definition of distance. That is, distance is the actual length of the path covered by a body in motion irrespective of its direction. And guys, in the last video we had seen what is scalar quantities and what is vector quantities. So distance is a scalar quantity, as we told here, it is irrespective of the direction. And the SI unit, normally we write it in meters, but in this image, as you can see, if it is big, you can write kilometers. So smaller version is meter and the bigger version is kilometer. So now let's move to the next topic and see what is displacement. And one more thing, guys, distance and displacement are both like interconnected, but there's some difference. So now we're gonna see the same image, but there's some difference. That is, what is this dotted line over here? So we'll see this. So now in the same example, we're gonna draw a dotted line connecting A and C. Now we see that line AC is the shortest distance, because we had seen that distance was 7 kilometer, because we added the 4 and 3, and displacement is 5 kilometer, as you can see it is written over here. So it is going to be, of course, shortest distance. So now this shortest path, so this dotted line is called displacement, that is between the start, that is A, and the final position, that is C. So now what is displacement? So displacement is the shortest distance, as you saw earlier. Distance 7 kilometer, displacement is 5 kilometer. So displacement is shorter. So displacement is the shortest distance covered between the initial and the final positions of a body in a given direction. So from this you can guess that So from this that I've underlined given direction, from this you can guess that this is a vector quantity. And all displacements are distances. So if you see, like here there is a desert, I think so. Okay, so this is full desert only, but here like it is full sand, there is no road over here. So then this is only the distance, right? And this is the displacement also, there is no more shortcut. But not all distances are displacement, because if this was open, so this is distance, but how is this displacement? This is the displacement, right? And as I told you, displacement is vector as it depends on the direction. And for displacement, again the SI unit is meter, and for of course big you can write kilometer as shown in the image. Now let's see speed. So now we see that if you take example this as the road, so here there will be a speed breaker, here there will be a human, and full highway now after that human. So now it will, like, the car will be very speed, then slow, then very speed, then slow, and then it will go like by full fast. It is gonna go full fast. So now here we saw that it got slow, it got fast also. So speed is like related to this example that I gave. So we see that speed describes whether the motion of an object is fast or slow, as I told. And what is speed in simple terms? It can be thought as the rate at which an object covers some distance. So if you see in this example, if you take the speed of this much, it will be very fast. This much, it will be very, very fast. And this, it is gonna be very fast. But if you take distance at the speed breaker, it is gonna be like slow. So if you see a fast moving object will of course have high speed, and slow will have slow speed. So now what is speed? So the definition of speed is that the speed of a moving object is defined as the distance covered by it. So this much you can remember, but while writing definition, this is important, per unit time. So a speed of a moving object is defined as the distance covered by it per unit time. So per unit time is important. And the faster an object, the speed is going to be of course fast, and the speed depends on two variables, distance and time. And of course there is no this direction over here, direction is missing. That means it is a scalar quantity, and therefore does not contain any information about direction. And SI unit is, guys, not meters but meters per second. So now let's see, let's move to the next topic and see average speed. It is same only, but some different. So again, that example only we're gonna take. So as we saw in real life situations, objects do not move with a constant speed. As the cars, buses, trains, they will like stop in between as the school bus. It will be going, but when it is a halt, when it has to pick you up, it will stop. So during the full journey, it may speed up, slow down, or even stop, as I gave the example of the bus. And so in order to calculate the speed, we divide the total distance covered by the body of the total time taken. One more thing, so here I forgot to tell the equation how to find speed. So if we see the equation of how to find speed is distance traveled, not total distance, but in the question how much distance, that much distance traveled upon time taken. So you'll get the answer. Now let's continue. We were on average speed. So I was telling that we divide, so in order to calculate speed, we divide the total distance covered by the body to the total time taken, and this only gives us the average speed. So the ratio of the total distance traveled by the body to the total time of the journey is called average speed. And the formula for average speed is same as speed, and it is like total distance traveled upon total time taken. And you may think like, what is difference between speed and average speed? So if we take that example, I'll draw a big one. So there is one human, there is one bus stand, and there is a highway. So now if you see over here, if you have to calculate speed, in the question they may give all this thing, the full diagram and everything, but they will tell you to calculate speed till this bus only, the halt of the bus. But in average speed, of course it has to be total, the full road trip. So that's the difference. So now that's all for the theory part, but now for some practice we're going to see some numericals, that is we're going to solve some questions. And for this I prefer you to first do the solve the question and then see the answer key. So of course answer key is going to be in the description. So now let's see questions on distance. So you have to, it is simple, so you have to find the distance of the car in this image but with steps. And there is no questions for displacement because we haven't seen how to find this. That is called in scientific term Pythagoras theorem. So we haven't learned how to see that, but yeah, we will see in further videos. But of course for that there is no question for finding displacement. Now let's see some questions on speed. So it is going to be first question. Calculate the speed of a car which travels 50 kilometers in half an hour. So half an hour, I'll give you one hint. It is going to be 0.5 hours. Of course, you can't write kilometers by minutes. It is kilometers per hour, not kilometers per minute. So you have to remember that also. And the second question is, calculate the speed of an object if it covers a distance of 150 centimeter in 5 seconds. So one more hint in this question, you have to convert this 150 centimeter into meter. Next is, a train is running at the speed of 60 kilometers per hour. Sorry. So here speed is already given. So the speed formula, I'll just once write it and I'll just show it also. So it is distance covered upon time taken. So I'm just going to write that. I'll write distance as d and t as time. So now here they have asked to find the time. So how will you find time over here? So we'll just put this s over here and t over here. So we are going to transpose. So time is going to be distance upon speed. So this is one more hint. So I'll read the question once more. A train is running at a speed of 60 kilometers per hour. How long will it take to cover a distance of 240 kilometers? So you have to divide these both units. Magnitude. You'll have to divide the magnitude. Now let's see questions on average speed. So again, it's a question. It's a picture based. So if you see the picture over here, you have to find the average speed of this car. And now that's all questions, like only 5 questions for this video, but yeah, there will be more questions in the further videos. So now let's do just a quick summary. So we saw that we learned distance as it is meter, and scalar or vector it is scalar. We saw displacement meter, and this is vector. And speed it is meters per second, the SI unit, and scalar or vector it is scalar. And average speed, like as I told you, if the SI unit is big, so it will become kilometers per hour, and if it is small, it will be meters per second only. And scalar or vector, of course it depends. Average speed may be any scalar or vector. So guys, that's all for this video. I hope you all liked the video, and thanks for watching everyone. And if you like the video, what you have to do? What? So if you have liked, you have to like, share and subscribe to my channel. So guys, that's all for this video. We'll meet in the next video with more information. So goodbye guys.